All right. Hi, everybody. So we are on part two, where we are going to write the equation for our rational function. So here's the steps. Again, if you notice, the steps are very similar to the last one. The only thing that's different from the last step in this one is our function. So our parent function, our general form of the function that we're going to use. But we're going to go through the process the same way. We're going to fill in our table, take a picture of our work, and insert it into the table. Now, remember that when you're filling in the table, you're filling in the column A, H, and K, right? We're going to fill in the restricted domain and range, the center point, the y-intercept and behavior and roots, right? Want you to do your work separately for the rational when you find A, because there's a space to put it by that just by itself. And then the other space is going to be for your key features. All right, so that's where you're going to put that. All right, and then that will be it for this part of the video. So let's go ahead and get started. First things first, we have to go to our Jamboard and we have to find our endpoints. So the beginning and the end. So let's go ahead, and we said that, and I wanted to use a different color than what we used on our screen. So I'm going to use a bright green. Okay, I think that will stand out. All right, so endpoints are going to be this point and this point. Okay, that's going to be the endpoint. Now the question is, see, hyperbole is a little different, right? The center is not where you think it is. Okay. The center is like not one of the endpoints like it is for the radical. So when you look at the parent function for the hyperbola, notice that our center was right in the middle here. It's right here in the middle. So the center is actually where the asymptotes intersect, because the hyperbola has a horizontal and vertical asymptote. So, with that said, we got to think about this now. When we go to our Jamboard, let's go back. We have a vertical and a horizontal asymptote. Where is our vertical and horizontal asymptote intersecting? So let's go ahead and do different color. Let's do like hot pink. And we're going to draw our vertical and horizontal asymptote. Okay. So let's say it is, I don't want to say it's right on here, but let's say it's right about there, right? And I'm getting really close to that line, but I'm not touching it, right? And then the horizontal asymptote, let's put it right here. Actually, I'm going to do one over more. Okay. I'm going to do one over more because remember, it's an asymptote, so it's not going to touch the line. So the same way did like one down a little bit, I'm going to do one over a little bit. And if I do one over, that puts me back on the y-axis. All right, so there goes my vertical and my horizontal asymptote intersecting, which means my center becomes this point here, this one right here. So this is my endpoint. That's my center. All right, so, right. So we're going to use this. Let's use this endpoint as a starting point. Okay. Well, let's just use it as an endpoint, because remember the center is going to be what we just found, right? So this is just going to be my endpoint. And the center is going to be here. That's the center. What's that location? That's going to be 1, 0, 0, 1, 2, 3. So that's going to be 0, 3 for my center, which means this is going to be H, and that's going to be K. And this point right here is going to be, let's go ahead and draw to the x-axis. That's 1, 2, 3, 4, and 5. And this point here, hold on. All right, so that's 3, so that's 4. Okay, so that point is going to be 5, 4. That's going to be my x and my y. Okay, now I'm actually going to go ahead and get this other point here, this other endpoint. Okay, and here's the reason why, because that's going to help me determine how to restrict my domain and range. So that's why I'm going to go ahead and get this other endpoint. All right, so let's go here. And where is that located? Let's see. So this is located at 1, and that's 5, and that's 6. Oh, that looks familiar. I remember that because that's the same point that I used for the radical. So that endpoint is 1, 6. Okay. And so I'll keep this in mind again, x, y. So I can either use either one of these points for my endpoints, but this is going to help me restrict my domain and my range. Okay, so that's why I found it. So now that I got all my pieces, let's go back to the steps and let's make sure I'm on the right track. Okay, so let's look at our steps. So we have the point 0, 3 as my center, right? And then we have 5, 4, and 1, 6 as the endpoints. All right. So as we mentioned, this would be H and K because this was the intersection of the vertical and the horizontal asymptote. Our vertical asymptote was x equals 0. We call that VA, right? Our vertical asymptote was x equals 0. Our horizontal asymptote was y equals 3. Okay. And so that's how we got our center. Get it? 0, 3. Okay, it's the intersection of those two lines. So we are ready to go to the next step. So that means that one of these points has got to be X and Y. So I'm gonna let 1, 6 be X and Y again. So here we go. Here's our function. Y is equal to A over X minus H plus K. So now we're going to plug in our numbers, right? We know that Y is 6. We know we're looking for A, right? We know that H is 0. We know that K is 3. And so now we need to fill in everything else. So 6 is equal to A is on top because I got to solve for that. X minus 0 plus 3. Okay. So now let's clean this up because I got to isolate X. That's my job. I got to isolate. Hold on. I know what X is. Let's go back because I know what X is. X is 1. X is 1. Can't have two variables, y'all. That's what threw me off. I cannot have two variables. When I saw that, I was like, that don't look right. I know X, I know H. So that's got to be 1, okay? Because we know what X is. So now we know X, we know H. What we don't know is A. That's what we don't know. So we got to solve for that. All right, so let's take our time. So 6 is equal to A over 1 minus 0 is 1 plus 3. What's A divided by 1? All right, that's A. And I'm just using the order of operations here. I started with doing the denominator and subtracting that. Um, and then we A over 1, any number over 1 is going to be itself. So now I'm going to isolate A by subtracting 3. The 3's cancel, so A is equal to 3, like that. So now I'm ready to write my function. My function is y equals 3 over x minus 0 plus 3. Now you don't even have to write the x minus 0 part, right? So this is the same thing as saying y is equal to 3 over x plus 3. That's the way you can write it if you want to. All right, so check, right? Check on the starting point, check on the equation. Now we're ready to talk about the key features. Okay, so let's start with the restricted domain and range. Let's start with that. As we mentioned before, the nice part about seeing it on a graph is you can see where your domain and range are restricted. And I'm going to do this in a bright blue. So hold on. I thought I was going to do it in a bright blue. Here we go. Bright blue. So 1 to 5 here. So that's my domain from 1 to 5. And my range, okay, that's these values here of the two coordinates that I'm looking at, is going to be, because remember, I'm looking at these points right here. I'm looking at these points. So this point was 1, 6, 1, 6, and this point was 5, 4, 5, 4. So my domain is going to be the 1 and the 5, right? My range is going to be the 4 and the 6. So 4 is the low one, y, and 6. There you go. I got my restricted domain and range from just looking at the graph. So let's go ahead and fill out our table. All right, so A is 3. Let's go get my trusty handy writing tool. A is 3. H is 0. And K was 3. Okay, so our function was y equals x3 over x plus 3. Okay, now let's look at the restricted domain. We said the restricted domain was 1 to 5 and then 4 to 6. So 1 to 5, 4, y to 6. So x is between 1 and 5, y is between 4 and 6. Our starting point was 0, 3. Now we just got to find the y-intercept, x-intercepts, and remember this means x-intercepts, and the roots. Excuse me, the end behavior. All right, so let's go ahead and get started. We're going to let x equal 0. So y is equal to 3 over 0 plus 3. Ooh, flag on the play, flag on the play. That's a red flag. Okay, I cannot divide by 0. Cannot divide by 0. For that reason, there is no y-intercept. Now, this is not going to happen for everybody. This happened to me, though. So my conclusion is there is no y-intercept. Okay? All right. So next, let's go ahead and find the x-intercept. So we're going to let y equal 0. So 0 is equal to 3 over x plus 3. I'm going to subtract 3 from both sides. And we get 0 minus 3 is negative 3 is equal to 3 over x. Okay. Now, when I have like problems like this, I make this number a fraction normally. So that's negative 3 over 1. I can do that. That's a legal move. All right. But now when you look at it, it's a fraction equal to a fraction. And now that I have a fraction equal to a fraction, I can multiply this fraction. Excuse me, I can do my means and extremes to set up my equation, right? I can go ahead and say 1 times 3, and I can say 3 times x cross multiply to go ahead and find my answer. So here we go. 1 times 3 is 3. And 3 times negative 3 times x is negative 3x. Divide both sides by negative 3 to isolate x. And x is equal to negative 1. X is equal to negative 1. Yay! So what does that mean? That means my y-intercept, excuse me, my x-intercept is negative 1, 0. That's my x-intercept, negative 1, 0. So my y-intercept does not exist, and my x-intercept is negative 1, 0. That's where it's going to cross the x-axis. Now let's talk about end behavior. All right, so I'll go back to my Jamboard. This is looking kind of messy, but let's go ahead and let's download that. Then let's go ahead and clear this. All right, so let's talk about end behavior. Now, this is a hyperbola. Now, for a hyperbola, look at the parent function. Hyperbola looks like this. Okay, so the end behavior on the left-hand side is going on to, as x approaches negative infinity, as x approaches negative infinity on this side, what's y doing? Y is going off to 0, getting really, really close to 0. It's not touching 0, it's just getting close to it, right? And that's why we say we have an asymptote, because it's getting close to it but never touches it. On the right-hand side, what is y doing over here? It's again getting close to 0, but never touching it. So now let's go to our Jamboard. This is we already said that our asymptote, let's pull up our asymptote again. We said our asymptote is x equals 0 and y equals 3. Okay? So with that said, then what is happening on the, say, left side? Our branch on the left side would actually be like right here, right? That would be the other branch to this one. That's what would happen. So we know that on the left side, okay, on the left side, meaning negative infinity, what's y doing? Y is approaching the asymptote of 3. That's what's happening. Okay. And on the right hand side, which is this line right here, what is y doing? It's also approaching 3. So because it's an asymptote. So on both sides, on the left side and the right side, our graph is approaching 3. All right. So remember, left side is the same thing as saying negative infinity. Right side is the same thing as saying positive infinity. But notice that on the left side and the right side, they're both approaching the same number. Never touching it, just approaching it. And that's going to happen with hyperbolas, not all hyperbolas, but this one in particular. That's going to happen to them because we have vertical and horizontal asymptotes. All right, so now we're ready to fill in our chart. So here we go. I filled in a chart with our and the behaviors here. Okay, so let's download that so we can go ahead and clear the screen so I can show you something else. So remember, your work is going to go down here where it says rational, where you found A. That's a separate work that you did. Okay. And then the work that you did on your key features, you're going to put right here. Okay. And we just got one last thing to do to make sure we are good to go. So let's go do the verbal description of the transformation. So here we have y equals 3 over x plus 3. Let's talk about what transformation is. So y equals 3 over x plus 3. Okay, so here we go. This was vertically stretched by a factor of 3. So that's a dilation. We talked about this before. That's going to be a dilation, like we did in unit 1. So that's going to be a dilation by a factor of 3. Okay, it was not shifted to the left or right, so we're not going to say anything about this x here because x is by itself. But it was shifted up 3 units. So there was a vertical shift, 3 units. So that's a translation, right, from unit 1. And if I were to write this in function notation, that would be T03, right? The dilation would be what, D3? That would be the function notation there. And that's how you do the work for rational function.